Welcome to online digital classes. Students, today I brought an interesting and an exciting math content for you. Get ready with your pens and books, and without making any delay, let us jump into the topic. By the end of today's class, you will be able to use laws of exponents in the process of simplification, and you understand the importance of exponential form, and you convert usual form to standard form and vice versa. You observe here this sentence, 5 is multiplied by itself 7 times. How do you represent this sentence in mathematical expression? 5 is multiplied by itself 7 times. 5 into 5 into 5 into 5 into, like that we multiply itself by itself 7 times. But now you read this sentence, 5 is multiplied by itself 100 times. How do you write this? Obviously you will write 5 into 5 into 5 into 5 into 100 times. It may be a bit difficult to write those many 5s, but is there any short form to represent this mathematical expression? Let us see. We shall now discuss exponential form. Look here, multiply 4 by itself 3 times. How do you represent this in mathematical expression? 4 into 4 into 4. 4 into 4 into 4, that we write in short form as 4, which we are multiplying here 3 times, and we write 3 here. This we read as 4 raised to the power 3, 4 cube or 4 to the power of 3. So here what does this 4 represents? 4 is the number which we are actually multiplying, and what does this 3 represents? 3 times. 4 is multiplied with itself 3 times. Now you observe here, multiply 10 with itself 7 times. How do you write this? 10 into 10 into 10 into 10 into 10 into 10. Like this 7 times we multiply 10 with itself, and this we write in short form as 10 to the power how much? Here how many times we are multiplying 10 with itself? 7 times. So we write 10 to the power of 7. Now you observe here 2 into 2 into 2 into 2 into 2 into 2. How do you write this also in short form? We write as 2 to the power of 6. Why did we take here 6? Because 2 is multiplied by itself here 6 times. So we write 2 to the power of 6. Now you observe this is expanded form and this is exponential form. Now you take this exponential form. In this we shall discuss different parts of this exponential form. Here this 2 is called base of this exponential form, and 6 is called exponent of this exponential form, and this total together we call it as power. 2 to the power of 6 is power. In this 2 is base, 6 is exponent, and we read this as 2 is raised to the power of 6. We read this notation as 2 is raised to the power of 6, sometimes 2 to the power of 6. Now let us learn converting expanded form to exponential form. Now you observe on the screen, let us try to convert each expanded form into exponential form. Observe carefully. For the first question, how do we write in exponential form? What is the number we are multiplying here? Minus 2, and how many times it is multiplied by itself? 1, 2, 3, 4 times. So we write minus 2 to the power of 4. If you write this like this, it will be wrong. Why? Because here in this representation, this 4 is considered to be the exponent of only 2. Here 4 is the exponent of only 2. It is not the exponent of minus. If you put brackets like this, now this will be the exact exponential form, where this 4 is now considered as the exponent of the total minus 2, because here minus 2 is repeatedly multiplied with itself 4 times. Whereas you come to the second question, how do you represent this expanded form in exponential form? So we write minus 2 to the power of 5, and you observe we don't keep brackets here. Why? Because here what is the number multiplied by itself 5 times? Is it minus 2 or 2? Here only 2 is multiplied by itself 5 times, not minus 2. So, this exponent 5 should not be applicable to minus, it should be applicable only to 2. That is why we write it as minus 2 to the power of 5. And you come to the third question. How do you represent this third expanded form into the exponential form? What is the term that is being multiplied by itself? 3a, and count how many times it is being multiplied with itself, 1, 2, 3, 4 and 5. And what should be careful about? We need to put brackets, because here 3a is the term which is repeatedly multiplied. So, this exponent 5 should belongs to the total set 3a. Now, look in the fourth question. Here 2 is not repeatedly multiplied. So, we write 2 as 2 power 1, because 2 is multiplied with itself only one time, into, and how many times 3 is repeatedly multiplied? 2 times. So, we write 3 power 2, and a is multiplied with itself 3 times. So, it is written as a cube or a power 3 and b square. Now, let us discuss powers with negative exponents. 10 to the power of 3. How do you write 10 to the power of 3? What is the value of 10 to the power of 3? It is written as 10 into 10 into 10. That gives you 1000. And you observe what is the value of 10 square? We write it as 10 into 10, that is equal to 100, and you know 100 can be written as 1000 by 10. What does it mean here? Here from 10 cube to 10 square, the exponent is decreased by 1 unit, and when the exponent was decreased by 1 unit, the answer was 10th part of the previous value. It is 10th part of the previous value. Now, if you take 10 to the power of 1, how do you write 10 to the power of 1? 10 to the power of 1 is nothing but 10 itself, and we write 10 as 100 by 10. That means, here also the exponent is again decreased by 1 unit, and what happened to the answer? The answer is again the 10th part of the previous value. This answer is again 10th part of the previous value. Now, in continuation to this, I will take next 10 to the power of 0. How do you write 10 to the power of 0? It is 1, and I can write 1 as 10 by 10, and you observe the same pattern here also. The exponent is decreased by 1 unit, and thus the answer is again the 10th part of the previous value. Now, in continuation to this, how do you represent 10 to the power of minus 1, that is this power with negative exponent? How do you write this value? So, we should follow the previous pattern. This value should be 10th part of the previous value. What is the previous value? 1. So, in 1 we have to take 10th part, that means 1 by 10. So, 10 power minus 1 is 1 by 10, that is if the exponent is decreased by 1 unit and the value was the 10th part of the previous value. Now, you can write 10 to the power of minus 2 like this as 1 by 100, and 100 can be written as 10 square. Like that, 10 to the power of minus 3 can be written as 1 by 10,000, and 1000 can also be replaced by 10 cube. Like that, 10 to the power of minus 4 can be written as 1 by 10,000, and instead of 10,000 we can write 10 to the power of 4. And now, you observe, we can write the powers with negative exponents with some other basis. Now, you see 2 to the power of minus 1 means 1 by 2, 2 to the power of minus 2 means 1 by 2 square, 2 to the power of minus 3, can you guess what is the answer? 1 by 2 to the power of 3. Now, you observe, if you take 5 to the power of minus 1, what can be the answer? 1 by 5. If it is 5 to the power of minus 2, it is 1 by 5 square. If you take 5 to the power of minus 3, what is the answer? 1 by 5 to the power of 3. You observe all these terms and you observe the pattern how we are representing these powers with negative exponents. into the fractions 1 by 10 power 1, 1 by 10 to the power of 2 like this. We generalize this as, if a power is with negative exponent, that is a to the power of minus n is there, we can write this in other way as 1 by a to the power of n. This negative n here becomes n. This formula should be applicable only when a is a non-zero integer. Students, let us study about expanded forms. Now you observe the question given on the screen, 256.38. Now let us try to expand this using exponential forms. Place and place value, let us convert this into a tabular form. Now, and to the left side of this decimal point, this is ones place or units place, and the next one is tens place, and the next one is hundreds place. And to the right side of decimal point, it is tenths place, and the next one is hundredths place. These are the places of the given numbers. And how do you write place value of each number? 2 into 100. Here 5, we multiply 5 and 10. Here we multiply 6 with its place 1. Here we multiply 3 with its place 1 by 10. And here we multiply 8 with its place 1 by 100. Now the expanded form will be 2 into 100, this part, we sum up all these terms, 2 into 100 plus 5 into 10 plus 6 into 1 plus 3 into 1 by 10 plus 8 into 1 by 100. And you can write this 100, 10, 1, 1 by 10, these also in exponential forms. You observe here 2 into 100, 100 means 10 square, plus 5 into 10, 10 means 10 power 1, and 6 into 1, 1 means 10 power 0, and 3 into 1 by 10 means 10 power minus 1, and 8 into 1 by 100 is 10 power minus 2. So this is the expanded form of the number 256.38. Now let us discuss the laws of exponents. Students, you have already learned laws of exponents in your previous class, 7th class. There you discussed the laws of exponents with positive exponents, but in addition to that, in this class we are going to discuss these laws of exponents with negative exponents also. Let us discuss. Okay, these are the laws we are going to discuss in this class. These laws you have already discussed in your previous class, but we are going to discuss these laws again with negative exponents. Okay, let us see the first law. This is a to the power of m into a to the power of n equal to a to the power of m plus n. Let us verify, is this law applicable to negative exponents also or not. Let us take 2 to the power of minus 3 into 2 to the power of minus 2. Now you can write 2 to the power of minus 3 as 1 by 2 cube into 2 to the power of minus 2 as 1 by 2 square, and you can write 1 by 2 cube as 2 into 2 into 2 into 1 by 2 square as 2 into 2. 2 times we multiply. We multiply these two together and we write in a single term as 1 by 2 into 2 into 2 into 2 into 2 5 times. And how do you write this in exponential form? 1 by 2 to the power of 5, because it is multiplied by itself 5 times, we write it as 2 to the power of 5. And you know 1 by 2 to the power of 5, we can write it as 2 to the power of minus 5, as we discussed few minutes back. Now you observe 2 to the power of minus 3 into 2 to the power of minus 2, we got 2 to the power of minus 5. And you know already that this minus 5 is nothing but the sum of minus 3 and minus 2. Thus, this part exactly resembles the given formula. Thus, we can say that for every non-zero integer a power m into a power n is always equal to a to the power of m plus n, where m and n are any integers. And now look at, as you know, a power m into a power n equal to a power m plus n, we can extend this formula to any number of bases which are same, and there should be under multiplication. If all the bases are same and they are under multiplication, this formula can be extended to those all bases. Thus, we can simplify this problem in a single step as take a single base minus 3. Instead of writing 3 bases, we take a single base minus 3 and we add up all the 3 exponents, minus 3 plus minus 6 plus 10. That gives you minus 3 to the power of 1. How did we get this one? Minus 3 and minus 6 gives us minus 9 plus 10, thus we get 1. In this way also we can simplify this problem very easily. Now let us go to the next law of exponent. A power m by a power n equal to a power m minus n. Here 5 to the power, for example, you take 5 to the power of minus 3 by 5 to the power of minus 5. How do you simplify this part? Using this formula. According to this formula, we can take the single base a and we subtract the exponents. Thus we can write 5 to the power of minus 3 minus minus 5. We have to subtract minus 5 from minus 3. Thus we get minus 3 plus 5 and it is 5 to the power of 2. Now look at the third law. A power m whole power n equal to a power mn. For example, if you take 5 square whole to the power of minus 3. How do you simplify this part using this formula? According to this formula, what can we understand? If this base has already an exponent m and to this power n is another exponent, then we can multiply both the exponents mn. Thus you do the same here, take 5 and you multiply 2 into minus 3 and you get 5 to the power of minus 6. 5 to the power of minus 6 can be again rewritten as 1 by 5 to the power of 6. Now let us go to the next law. A to the ab whole to the power of m equal to a power m into b power m. Here to the two different bases ab which are under product, m is the common exponent. Then we can separate this m, we can give this m separately to a and b and we multiply the two powers. Now you take here 12 to the power of 5. How can we simplify this using, how can we expand this using this formula? We know that we can write 12 as 3 into 4. So now we take 3 into 4 and we write this 5 which is the single exponent to this group and we separately give this 5 to 3 and 4. Thus we write 3 to the power of 5 into 4 to the power of 5. Let us go to the fifth law. Here a by b whole to the power of m equal to a to the power of m by b to the power of m. This is the fifth law. Now you observe 5 by 6 whole to the power of 8. How do we expand this? Using this formula, we can write 5 by 6 whole to the power of 8 as 5 to the power of 8 by 6 to the power of 8. And now look at the sixth formula. You know this very well. You have already used this so many times in your 7th class also. A power 0 value is always 1, and students, you remember these all laws we are discussing for a non-zero integer a. And you take here 5 power 0 is 1 and 6 power 0 is 1 and 9 power 0 is also 1. Whatever the base it is, if the exponent is 0, if the base is a non-zero term but the exponent is 0, its value becomes 1 always. Now look at the 7th law. Here this law clearly says that if this fraction has the negative exponent minus n, a by b whole to the power of minus n, then what we can do, we can take the reciprocal of this fraction. A by b can be written as b by a and then the exponent becomes additive inverse. That means if it is negative n, it becomes n. Now we take one example. Here if it is 2 by 3 whole to the power of minus 3, it can be written as 3 by 2 whole to the power of 3. Fraction is inverted, I have taken the reciprocal, then the exponent became additive inverse. If this is minus 3, it became plus 3. Now the most important law of exponent, if a power m equal to a power n, then m equal to n. This is one of the most important laws of exponents. If 2 power x is equal to 8, then what is the value of x? How do we find x using this above formula? Now you see 2 power x is equal to 8 and 8 can be written as 2 cube. Thus according to the formula, if bases are same and the powers also same, a power m and a power n both are same, then we can equate the exponents. Here the exponent is x, here the exponent is 3, thus x equals to 3. But you observe students, here on the screen 1 power 6 and 1 power 7 are there. What is the value of 1 power 6? It is 1. What is the value of 1 power 7? It is also 1. That means RHS parts are same. Thus we should understand the LHS parts should also be same. That means 1 power 6 should be equal to 1 power 7. But according to the formula, if bases are same and they are equal, a power m is equal to a power n, then we can equate the exponents. Then you apply that concept here. Here both bases are same. Then you can equate the exponents 6 equal to 7. Is this statement correct? No, it is not the correct statement. 6 and 7 are equal is a wrong statement. Thus, this formula has some limitations. This formula we can apply only when a is not equal to 1 or minus 1. For other than 1 and minus 1 as the base, this formula can be applied. Okay students, we have seen so far some laws of exponents. Now let us learn how do we apply these laws in simplification of some problems. Application of laws of exponents. Look at this problem. 5 square whole cube into 5 power 4 divided by 5 power 6. Now here I take this problem and I can apply this formula a power m whole power n equal to a power mn to this part, because this part resembles this formula. So I can multiply these two exponents. I can write it as 5 power 6 into 5 power 4 divided by 5 power 6, isn't it? 5 power 2 whole power 3 became 5 power 6 and remaining terms as it is. Now again to this part again I can apply this formula a power m into a power n, because bases are same, they are under multiplication. Now after application of this formula we can write it as 5 power 10, because we have to add the exponent